Assalamualaikum and hello everyone. Today we're going to learn topic 4.3 Partition Coefficients KPC. First, let's take a look on the definition. Partition coefficient is the ratio of the concentrations of solute in two different immiscible solvent when an equilibrium has been established. So what does this sentence mean? Let's take a look on an example. So here I have ammonia, which is in aqueous solution, and we also have ammonia in organic solvent. So how does it look like? So for example here, you can see I have ammonia, which is in organic solvent, and I also have ammonia, which is in aqueous solvent. So you can see here, this red dot here is the ammonia molecules, and you call that a solute. Okay, and this ammonia, okay, it is soluble in aqueous, which is water, and it is also soluble in hexene or benzene, etc., which is the organic solvent. So it can be hexene, benzene, CCl4. Okay, but you can see that these two solvents, the organic solvent and the water, they are immiscible solvent. It means that they don't mix. It's like you have water and you have oil, so they don't mix. Okay, and if you look at the diagram here in the circle, some of the molecules of ammonia, it goes to the organic solvent, and some of the solute, the ammonia solute molecules, it goes to your water, and it keeps on going, and that is what we call equilibrium has been established. Even though the molecules from water goes to the organic, the molecules from the organic goes to the water, they still will have the same concentration because the equilibrium has already been established. Now let's zoom in into this diagram. So here, the red dot is the molecules of ammonia. We call it solute. Okay. And then this one, this white colored one on top here, that is the solution of organic solvent. You call it organic solvent. And down here, I have the aqueous, which is the water. Now, it's not always organic solvent. It's not always water. It will depend on the question. As long as these two solvents, they don't mix. Immiscible solvent. Now, what I want you to look at is that you can see down here, the ammonia molecules are more soluble. That's why you have a lot of this ammonia molecule down there compared to the one above. Because why? The ammonia molecules, they are more soluble in water compared to in organic solvent. Next one, what is the formula for KPC? So KPC is equal to the concentration of ammonia, which is the solute, the concentrations of the solute, this red dot here, in organic solvent, divide by the concentrations of ammonia, again, which is the solute, in water. Okay, so you don't just simply say KPC is equal to concentrations of organic solvent. No, you have to mention what is the solute, what is the molecule, this red dot here that you have. So ammonia in organic solvent over the ammonia in water. Okay, now you will ask me, teacher, how do I know which one goes on top, which one goes below? So here is an example. For example, I give you this sentence. The partition coefficient between the partition coefficients of Y between benzene and water is 36. So how do you know which one goes on top and then which one goes below? So one thing here is that, remember, partition coefficient is a ratio. So if you change this sentence in terms of a ratio, now it will read like this. The partition coefficients of Y between benzene and water is 36:1. So it means that this 36 belongs to benzene. This water here, the value is equal to 1. So if you express it into the KPC formula, concentrations of Y, which is your solute, okay, in benzene over the concentrations of Y in water. Because you mentioned benzene first. So benzene goes on top. It will be 36 divided by 1. So again, if this one, you equal it, simplify, it will become 36. And it is the same like this. Okay? Let's move on to the unit. Since KPC is a ratio, therefore there is no unit for KPC. But you have to make sure that these two units for the concentration here must be the same. Okay, so here it says it doesn't matter what unit these concentrations are measured in, provided that they are both the same. So it means that you can have mole per dm cube, gram per dm cube, even gram per cm cube. It doesn't matter. As long as what you use above here, it must be the same as the one below. So here you can work in whatever concentration unit are most convenient as long as the unit is the same for both solvent. It means that this unit here must have the same unit down there. Okay. Next one. What happens if you change the solvent? Okay. Or you change the molecules. So it means that here you change these molecules here, this red dot here, you change it. Like for example, just now I'm using ammonia. Now I'm using X, molecules of X. And then previous one, I'm using solutions of organic. And then the other one is water. But now I have water. The other I'm using ether. Okay. And you can refer back to the diagram before. It will be different than this one. Now you can see that most of the molecule is up here, indicating that the X molecules is more soluble in ether. So if it is more soluble in ether, the concentrations of X in ether will be higher. So if this is higher, then your KPC value will also increase. That is why it says if you change the solvent or you change the molecules, the value of the KPC will also change. Now the last one here is on application. You can pause this video and you can have a look what are the applications of KPC. What is the importance of learning this KPC? So you can see here the pharmacology, you can have the environmental punya consequences of this KPC, etc. So you can have a look on what is the applications of learning KPC. So that's all first for the introductions on KPC. The next video will be on the calculation using KPC. Thank you everyone.